Hello and welcome to this 4IT Tech Elite session, which will give you an overview of AWS Cloud. This is the first of 3 technical webinars hosted with Amazon Web Services and will be presented by 2 AWS solution architects, George Fonseca and Ahmed Zamzam. The other 2 sessions will be in March. On the 11th, we will look at data analytics on AWS, and then on the 18th, AI and machine learning on AWS. Just let us know if you would like to attend by replying to the survey email you will receive later this evening. But here and now, we have an overview of AWS followed by Q&A, so please jot down any questions into the questions panel on your GoToWebinar toolbar, and we'll cover as many as we have time for after the presentation before closing at 7 p.m. So I will hand over the screen to our speakers and welcome George and Ahmed.
Thank you, John. And accepting the screen. I believe that everyone can see it now. So welcome, everyone. Thank you for the opportunity. My name is George Fonseca. I'm a solutions architect at Amazon Web Services, AWS. And I have with me my colleague, Ahmed. Go ahead.
Hi, everyone. Thanks a lot for joining and giving us the opportunity to be here with you. I'm Ahmed Zamzam. I'm a solutions architect at AWS, based out of the UK, focusing on SMB customers.
Thank you. I'll be taking the lead in the first place, showing a few slides on the theory, but then Ahmed will do a demo for us to show us the technology in the clouds that we can use. Okay, so first question that I'll pose for everyone is, what is cloud computing? So the concept of cloud computing is to have the on-demand delivery of IT resources via the internet and with a pay-as-you-go pricing model. So what this means is that companies no longer need to buy technology in advance and buy capacity and reserve that capacity for their workloads. They can actually just use it when necessary. For example, you can take the analogy at home with electricity and light. So you turn on the switch and you get light, and you turn off the switch and you stop consuming the electricity again. So this is the same concept for the on-demand delivery over cloud computing. What can you do with it? And what do we see customers coming for cloud for? So the main reason, or the first reason for companies to join the cloud and do this journey, is for cost savings. So by only buying and by only paying what you consume instead of what you reserve, you don't need to do that investment in CapEx. You can go into a model of OpEx where you actually just spend as you need. And we have seen great amounts of cost reduction. For example, with GE, where they had in one specific project a 50% reduction in terms of cost. But that is a typical focus for the journey into the cloud. There are other compelling reasons in terms of cloud benefit. We can see, for example, in terms of staff productivity. Once you are no longer required to maintain your on-premises capacity, you can then focus on doing just the things that bring benefit to your customers. For example, at Sage, they consumed 500 less hours per year in terms of server configuration for their on-premises infrastructure. You have also situations of operational resilience. So the complexity of maintaining your backups and maintaining compliancy in terms of regulations can be quite a burden for some companies. And by having the cloud, by having infinite storage, you can one, have high availability of your infrastructure and your services, but you can also have a robust disaster recovery strategy. That was the situation with Expedia. They managed to overcome all of those challenges by adopting cloud computing. And finally, as a conclusion of the previous benefits, the business agility. If you are able to spin up resources just to test things and test new ideas, and if your developers, your teams can do that as well without any problem, they spin up, they test a new service, and then they roll back if necessary. This trial and error brings much more agility to your company in the sense that you can benefit from experimentation and bringing these new features to the market quickly. And we have seen situations, for example, most recently with COVID-19 and vaccines, the ability to increase your capacity in a way that you can compute much, much faster than you would be able to in the past. Increasing that capacity, again, with a click of a button, without needing to buy all of those infrastructures in advance. And then what would you do with it after you get the result? So these companies are able to scale and downsize whenever needed. For the second question on the where, so where do cloud workloads actually run? There's a concept that some people have the concept that running on the cloud, there's nothing there, so it's kind of a magical. And when we have this mindset that the cloud is magical, that's actually very good. It's because we have abstracted ourselves from all of that complexity. But it's important to understand what's down there, especially from a solutions architect perspective, to address something which is mechanical synthethy. If you know how the machine works, you will be able to get the best options and the best architectures to run your workloads. In terms of cloud computing, there are several perspectives, but the most common ones are the notion of region and availability zones. I will explain the concept from the AWS perspective. And from the AWS perspective, what you have is this concept of a region, which is a large geographical area. And within that region, you have availability zones interconnected with high-speed networking, allows you to have very low latency, and that allows you to distribute your workloads, your services, functions throughout those availability zones to achieve high availability. So if one goes down, you will still have the other one responding to requests from your customers. Within one availability zone, what you have is a multitude of data centers. So these are actually the locations where the machines are stored. And as you can see, an availability zone does not map necessarily to one data center, but multiple data centers in a very close range. Where are these regions, availability zones? Well, they are all across the globe. In the case of AWS, you have these locations interconnected with redundant private and public network, except for China. And you also have within these regions what we call direct connect locations, where you can, from your company, have a direct link to AWS without crossing the internet. That is faster, it's more secure, and allows you to have an amplitude of benefits in terms of usage of AWS services. But there are other things as well, things like points of presence. These are mostly used for CDNs in terms of distribution of content, but we see them most recently with things like 5G, and we assume that bringing the computing to as close as possible to where it's needed, it will bring large benefits for things like IoT in the future and self-driving cars, and again, 5G solutions, as I just mentioned. But the infrastructure of cloud is not just on these data centers. Nowadays, we now see the concept of hybrid technology and hybrid solutions, where things are no longer just running in a specific silo, but they are running on-prem. So the cloud has extended to reach out to your local data centers, to the data center that you have in a room back there on your company. Some solutions have been released by AWS on reInvent, in December. So you now have solutions like AKS Distro, which is the same technology that we run on the cloud, but you are able to run it, this Kubernetes cluster, on your own infrastructure with the same benefits that you have in terms of features from EKS. But you also have EKS and ECS, Amazon EKS, Amazon ECS. These are container products. So for Kubernetes and a proprietary solution from AWS. And with these solutions, with these container solutions, you can deploy them on premises, but you manage them from the cloud. So within your web console, in this case, AWS console, you can deploy more resources, you can scale it, you can manage it all from the cloud, but running on-prem. And you also have Outposts. Outposts, it's actually a rack that you can deploy within your data center. It's all hardware provided and maintained by AWS, and you can connect it to the rest of your data center. These are just a few solutions in terms of hybrid cloud, where you can run it on-prem. And these are quite important nowadays for data sovereignty. There are some countries that require data to stay within that country, and AWS or other cloud providers might not have the infrastructure on that country. So how can you be compliant? By bringing this technology in-house, either to your hardware or using AWS hardware, you can keep both computes and storage within your on-premises location. You can be compliant with those regulations, and you still get the benefits of the cloud and a centralized way to manage all of these resources and integrate them with the rest of the ecosystem of AWS, where you have many services to take advantage from. This was the where. So we've seen the what, we've seen the where. The next question is the who. Who actually runs and is responsible for the workloads that are running on the cloud? In terms of AWS, we have a shared responsibility model. For this shared responsibility model, AWS is responsible for the security of the cloud, that underlying infrastructure, that hardware that is running on the cloud, while customers are typically responsible for the security in the cloud. This is mapped to best practices, the recommendations that AWS provides, the documentation with those best practices and frameworks to respond to the requirements in terms of safety, in terms of reliability, and all sorts of protection of your workloads. And also by using the mechanisms that AWS provides for you to monitor your own ecosystem, so your ecosystem of solutions. You have tools to monitor, you have tools to automate the correction of your environment as it changes dynamically, as your teams change it. But it is a shared responsibility here where AWS is constantly help you, but the customers need to follow these patterns and analyze themselves and act to maintain their compliancy. How can AWS help in this perspective? Especially for compliance regulations, the less a customer is responsible, so imagine yourself, the less you are responsible for the complexity of the hardware and the services that are running on top of your hardware, the better. If you can offload that responsibility to AWS or to your cloud provider, then you start focusing more and more just on the workload, so just on the benefits of the application that you're actually building. On this diagram, you have on the left, you have solutions where you start from on-premises or the closest from on-premises and move it to the cloud. You move your virtual machines and then you move it to EC2 instances, which is the equivalent on the AWS world. And if the more you go to the right, the more you get the serverless features. So you get the same features, but without the overhead, without the concern of those services that are running underneath it. So you have solutions like Lambda, like DynamoDB and S3, where you actually you don't know the existence of the services that are running there and are supporting those features. And you have, in the middle ground, you have solutions like RDS Aurora, where you do see the servers, underneath it. You have the responsibility to decide when a patching of the operating system, for example, needs to be applied, but AWS provides the updates and the patching for you according to your requests, according to your preferences and your workloads, so adjusted to your workloads. So one spectrum and to the other, for you to get an understanding of where AWS would like to be. Andy Jassy, which is the CEO of AWS, he said at a certain point that if we would to rebuild AWS from scratch, then we would certainly use the serverless strategy to rebuild the existing services. So this is how we think that the developers and the companies should target for the future for the building new solutions. We also see it, apart from serverless, we also see it on the machine learning stack. What you have in front of you is the machine learning stack from AWS. And within this stack, I would like to emphasize 3 layers. Right in the bottom, you have frameworks and infrastructure. So these are the frameworks for infrastructure that AWS supports, allowing specialized data scientists to build complex algorithms. Then you have, in the middle layer, you have a platform, so a studio that has a full set of features that you can use to produce machine learning algorithms and make it run them, so inference points and so forth. So everything you need, but it gives you all of this flexibility with the tools that you can interact with and join together to get your results. But on the top layer, you have the AI services. And these AI services are targeted specifically for certain objectives. You see, for example, search mechanisms, you see chatbots, you see forecasting. This is the result of many years of usage of building and using machine algorithms within the companies that consist the Amazon ecosystem. And with these learnings from our data analysts building these machine learning algorithms, we've taken these learnings and we are now giving them to the community so that you can easily interact with these services. For example, on the AI services layer, you can call an API and just request for the chatbots. As you're speaking to Alexa, for example, is a good example. You can do this kind of Alexa interactions, but just by calling an API using JSON, and you will get the results without being concerned with how that algorithm, that ML algorithm was built, without being concerned about the services that are running underneath it, the servers that support that feature, and the hardware that supports that feature. So you can see it as a complete abstraction of machine learning to give you these AI capabilities. So it's another perspective from the shared responsibility model, where you will need less and less to worry about infrastructure. You're really focused on the outputs and the benefits for your end customers with the solutions that you come up with. You're putting those ideas into practice and creating products based on them. And if we look at the ecosystem of services, the plethora of services on AWS, there are quite a lot nowadays, and they continue to grow in a fast pace. According to Gartner on their last report for cloud computing, AWS has been the most performant cloud company for the last 10 consecutive years. But these building blocks, what they do is they give customers the power to build those fantastic applications, But again, with this responsibility, the shared responsibility model, you'll join the building blocks to get some results, and you have to account for the best practices in terms of security, things like the well-architected framework that we provide to customers to check if you're following those guidances to make sure that your workload is not only performing as you want, but is as secure as it can be, and it's as resilient as it can be. But this is a lot of theory. What I would really like to do is I would like to ask for help from my colleague Ahmed, so that he can show us an example on how we can build such solutions in a very, very short time. Ahmed.
Perfect, thank you. So can you share with me the...
Yes, sorry, I forgot that part. There you go, make presenter.
So, perfect. So, do you see my screen?
Yes.
Perfect. So, thanks, George. This was very useful. So we've prepared like a short demo for you to show you how to deploy a serverless static web application. So this is how it would look like. First, let me put, sorry, I have two screens, so you'll see me looking at this screen. So we have the we have the end users here. The end users will be logging into your application that will be hosted on a service called AWS Amplify. AWS Amplify is a fully managed service, or it's a set of tools and services that you can use, customers can use to build, deploy, and host web applications and mobile applications. So how it will look like: end users a website will be hosted on Amplify, and end users will log in directly to Amplify. And then we'll also have we'll show you how to deploy the web application. So we have code already in a Git repository, which is in code commit. Code commit is another fully managed service. It's basically a source control, version control service that enables you to it's Git-based repository basically. So developers will be pushing code to code commit, and Amplify will be monitoring code commit and automatically deploying the application, and end users can log into it. Then Amplify will produce like I would say, a non-user-friendly URL or domain name. So what we'll do, we'll put this behind a more user-friendly domain name, and for this we'll use Route 53, which is our fully managed DNS service. And after that, we'll add authentication to our application. And how we'll do this? We'll use a service called Cognito, and again, Amplify will orchestrate everything for us. So you don't need to know all of these services. You will mainly interact with Amplify. What's this web application? It's an application where you can basically book unicorn rides. It's a fictitious application, so it's not a real one, but it's just to show you how this works. And there is also this link here that you can see in front of you. You can use this link to build this yourself and deploy it, and build on top of it by adding an additional layer, which is the API dynamic calls by booking unicorns, which unfortunately we cannot do due of time. So without further ado, let's get started. So so this is the AWS console. You can see here that the search bar, you can search for any service that you're looking for, and then the services, you have all the different services. They are organized under each domain. So it's fairly intuitive and very easy to use. And here you can see the different regions that AWS supports. So all 24 regions you can find here. And for this demo, we'll be using Ireland region. So we'll stick to Ireland. So first thing, let's go to code commit. So as I mentioned before, code commit is a fully managed source control service that enables you to host secure Git-based repositories. So here you can see two repositories created. They're both identical. And if you click on one, you'll see the code. So developers finished working on the code. You'll see all the JavaScript, HTML, CSS files here, and also a build spec for Amplify to understand how to build the environment and provision the environment. So everything is already available inside the repository itself. And then Amplify will use this to deploy to the application. So if we go to Amplify, you'll see that there is already one app created that I created before the demo, but let's create one together. So Amplify supports all of these. There are two options you can do with Amplify. Either you could use Amplify to help you develop the web application. So it helps you like integrating your front end with your back end with any resources that you provision in the back end. Or you can use Amplify to host your web application, and that's what we'll do right now. So with this option, Amplify supports these repositories and Git-based repositories, and the one that we're interested in is code commit. I hope you can see my screen well and it's not too small, the font. If we click continue,
Looks good.
Yeah. So if we click continue, we'll see two repositories here. So this is the one that we're interested in. It's also able to automatically detect the branches inside our repository, but we only have one branch. But if you want to if you deploy any changes to maybe another branch and you want Amplify to monitor this branch and detect any changes and automatically deploy those changes, you can easily do this. So we'll select master. And then here, Amplify was able to detect the frameworks that were used. We're using Vue and we're using Amplify as a backend. So now Amplify knows that the Amplify itself will host this web application. I'll explain this in a little bit. What do we mean when Amplify itself is hosting the application? Then what you need to do here is you're telling Amplify what should Amplify do when there's a change to your code. So when developers are committing code to the repository, what should Amplify do with this change? So we'll create a new environment and we'll call this environment prod. And then we need to give Amplify the permission to create resources on our behalf and also connect to the repository. So permission is given as an IAM role, and think of an IAM role as an identity. This identity has a set of permissions that are allowed to do something. And this identity, in this case, could be attached to a user, or it could be attached to a service. In this case, it's attached to a service and it's Amplify. Amplify was also able to detect the build spec that I was mentioning earlier. So it will follow these steps to build the environment in production. Click next. So the only thing that we did, we connected Amplify to the repository and the branch and gave Amplify the permission, and that's it. Click and save and deploy. This now should take us to start creating the app for us. So it should still be running. Anyway, so now if you look at, these are the different stages that Amplify will have to go through. This should be still running because we've just deployed it. And then if we go to, so this is identical. So this is pointing to our repository, which is Wild Rides 1, and this is pointing to another repository, which is Wild Rides. So they're both identical. It's the same, exact same code. It typically takes around 4 to 5 minutes for the application to be deployed, but I didn't want to wait this time before basically doing nothing. So that's why I provisioned one before the demo. So you can see here the different stages the Amplified went through. You can click on each stage to find out more details. So here, for example, you know that Amplify used a Docker image for the build environment with 4 vCPU and 7 gigs of memory. Obviously, you can change this. And then here you'll see the domain for Amplify. You can see that it's not very user-friendly. And then this is the source repository that Amplify is connected to. So any change to the source repository, Amplify will automatically detect this change and deploy the application. So if we click on this, this is how the application looks like. Can book unicorns with the application. So as you can see, it's not very user-friendly. So let's map this to a user-friendly domain name. So for this, we'll use Route 53. So I already have a domain that I own in Route 53. You can also use any third-party domain if you want, third-party domain provider if you want. So we'll add a domain here. And then because it's Route 53, we're able to automatically detect the domains that I have. And this is the domain I have. It's still not very user-friendly, but at least it's better. And if you have your own domain in a third-party provider, you can just simply write the domain name here and then configure domain. But since we already have a domain, I'll use mine. Anyway, Amplify will make sure that you will verify that you actually own the domain. You can leave the rest as the default. Basically, you're saying what are the records that you want to add to Route 53. So how do you want to handle traffic coming into the root domain or any subdomains, and whether you want to redirect traffic coming into the root domain to a subdomain like www, for example. But we're only, we can leave the rest as default. Just click save. And again, this will typically take around 5 minutes. And what's happening is that we're provisioning, Amplify is provisioning SSL certificates that will secure traffic to your web application. And it will use Amazon Certificate Manager for this. Amazon Certificate Manager is a service that you would use to provision public and private certificates for your web application. And then after that, it will validate that you actually own the domain, and it will add the necessary records inside your Route 53 hosted zone. So this will take around 5 minutes. So now let's do a small change. So you can see here the title says Wild Rides V1. Let's make a small change to the application. So let's say the developers push the change. Let's see what will happen. So for this, we'll go to terminal, our terminal. And our terminal is I'm using here Cloud9. So Cloud9 is a cloud native or cloud-based IDE. You can use your own terminal, but in this demo, I'm just using Cloud9. So this is how it looks like. So I hope you can still see this well.
A bit smaller,
so let me
but
open it.
Yes, it's okay.
Okay. Yeah, so I'll change the version to version 2. Then I'll save. Let me zoom in a little bit. Okay, so now we saved. Let's push. And give push. Perfect. And if you go to amplify, immediately you'll be able to see that you can see the one that we created earlier was successful. So if you go to amplify, you'll see that it's provisioning because it was able to detect that there was a change to the repository that we just pushed right now. So it's building the environment again and deploying the environment again. And this again will take roughly 3 to 4 minutes. So, and the good thing about it is that the application remains fully available when the deployment is happening. So you don't need to worry about this. So if you click on this, it's still fully functioning and fully working. And it says here V1, so it's still the old version of the app. So if we go to domain management, so still the SSL is not finished. And give it 1 more minute, should finish. Meanwhile, I can take you to Route 53. So Route 53, you'll find here. So with Route 53, you can have public domains. You can host public domains or private domains. So public domains are accessible by everyone, and private domains are accessible by your company, for example, or private networks. So my domain is public, and you can see here that CNAME was added to the CloudFront distribution. So how Amplify hosts the application, so it's finished. This now will work. I'll show it to you now. So how Amplify works is that when it deploys the app, it deploys under the hood. It deploys the app in a CloudFront distribution. So CloudFront is a fully managed content delivery network that accelerates the delivery of your web application to your global user base. So Amplify deploys this into a managed S3 bucket inside a managed CloudFront distribution, so you'll not be able to see it inside your console. And then what's happening here is that when we added this domain, the Zamzam domain, it basically mapped this domain to the CloudFront distribution. So if we now copy this domain, this should work now, even before the domain activation. And you can also see here V2. So this is the domain, and it's mapped to our application. And now we have the version 2 that we've just added. Now, last thing I want to add is the authentication. So let's go back to Cloud9. Let's clear the screen. And for this, we'll use Amplify CLI. So Amplify CLI is a toolkit, a command line utility that you would use to help you build the necessary backend resources and also help you integrate the backend resources with your front end. So with Amplify CLI, you can add something like authentication with a single command, and you'll see right now. So first thing we do, we need to initialize the CLI in this app. So it has to be the same name as the one we named before. We put the environment as prod. We choose the default editor, any editor, and this will take around 1 minute to initialize. Then here we're basically telling Amplify the permissions. So it will take the permissions that I have, the user that is logged in, and this will take around one minute to finish. So now we're just initializing the project. inside the directory, the root directory of the application. And then what we'll do, we'll add, with a single command, we'll add authentication to the application. Just while this is going, I just want to show you the authentication. So this is the current app. We have the static content for authentication, but it's not like integrated with any backend. So this is the user that I'll use later. Let's put in user. So you get authentication error. This is not currently not integrated with any backend. So we go back to Cloud 9. This finished. Now let's clear. Now we can add amplify with this. So amplify, we can add the authentication with this command, amplify add auth. So what will happen? Amplify will add the CloudFormation script. So CloudFormation is an infrastructure as a code service. You would use CloudFormation to deploy AWS resources into your AWS account. So it asks you a couple of questions. So we'll choose the default configuration. It asks you how do you want users to log in, username, email, or phone number, or both. So we'll choose username, and then that's it. I'm happy with the changes. That's it. So normally we have to do amplify push, but we don't need to do it because anyway, amplify is monitoring our GitHub repository. So we'll just push git add, push, and then git commit. Okay, you can see 6 files were added, and then git push. And if you go to amplify console again, you'll immediately see that it's so this is the backend app that we just created for authentication. It was added automatically during the initialization, and now here it's picking up again. So what's happening is that it's provisioning the environment again, and this time it will add authentication. This will take around 5 minutes to deploy. I don't want to wait for 5 minutes. I just wanted to take you back really quickly to the presentation. Yeah. So hopefully after 5 minutes, I don't think there is enough time, but hopefully after 5 minutes, I can show you the authentication part. So you can add a user incognito and then log in with this user. So now we have a fully functioning application. In 15 minutes, we were able to deploy this in using Amplify. And if you want to add the API element to the application, you can always do it. Unfortunately, we cannot do it in this demo. And this is how it would look like. So we'll use API Gateway, and behind API Gateway, AWS Lambda that George was talking about, our serverless compute service. And this link here, over here, you can go through the steps required to create everything from scratch. It doesn't include the Route 53 part. This is something that I've added, but the rest is included. So I don't think it will be finished. So maybe at the end I can show you the result. So it will take at least 5 minutes. So instead of waiting, we can go back to you, George.
Thank you, Ahmed. That was quite amazing. So you did, let me turn on the camera. So you did in just a few minutes what I would usually take a few days, and you did it online, so no nets. Quite amazing. Thank you for that. I will now request you the screen, please.
Yeah.
So quite an amazing demo. For those that are listening, I'm sure you will have different types of experience on AWS. Also different roles. Some of you might be developers, some solution architects, and some are probably business owners. Nonetheless, the idea of this demo is to show how quickly you can, with a few clicks and mixing different tools, how you can build this type of solution. And also with that confidence that things will work, didn't break, didn't have any problem. So moving on to the next question. So how to move to the cloud? What we have seen are different patterns in terms of this journey to the cloud. We've seen some companies going cloud native, others going into a phase of migration and then modernization. The idea is to reach a point where you can constantly innovating and reinventing yourself within the cloud. That is the example of Netflix that everyone knows from video stream. We have companies, startups usually that go through the cloud native route. So Lyft is a ride sharing startup. They start in the cloud, they progress in the cloud, and everything they do is completely 100% on the cloud. Other companies are much older, from the time that cloud did not exist. That is the example of Formula One. They had their own workloads and data centers, and they took the route that we usually recommend, which is create this project, understand what you're going to do the migration to the cloud, and then once you are already on the cloud, then modernize, start moving that shared responsibility model closer to the right to get into either shared responsibility in things like RDS and databases, or completely serverless by using Lambda and DynamoDB and these sort of serverless services. On this journey, there are many tools and ways that AWS can help. So we typically break it into assess, mobilize, and then migrate and modernize. Some of these steps, you can do it regardless of the cloud that you're migrating to. So it's a good thing, it's a good practice. We see in the future that most of the companies will migrate to the cloud, or at least have some sort of hybrid infrastructure or hybrid architecture where most of the workloads are on the cloud, and some of them for specific reasons and valid reasons are on-prem. But this is a need for all organizations for the future. By doing this assessment, and we can help on that assessment, no cost on top of it, so all free help that you can get, you will get that assessment about the ability of your company and your organization to go to the cloud, and then you can choose whatever you decide it's better, but you will take an informed decision. Once you are in the cloud, then it's time to automate and reinvent. Again, many tools, so CI/CD tools, infrastructure as code, IDEs. Ahmed mentioned many of this, actually showed many of these working. So this is for those highly specialized development teams, or for the startups, or for the DevOps teams that work very closely with both code features and analysis, and also the deployment, release, and testing, and the entire life cycle, and the entire software development life cycle and the life cycle of your applications. But you're not alone on this move to the cloud. So on this journey, there are many teams within AWS that can help you. So we have professional services that can help you actually build the thing, but you can count on AWS support or managed services to help you manage your legacy infrastructure. And you have training and support, and a set of thousands of partners that can help you on that journey, on specific steps of the journey, or the entire journey as you wish. And we can onboard your partners that you're already working on as well. So that leads us to the final question. When should I move to the cloud? Well, the first thing you will need to do is get some hands-on, some training, but the answer typically is today. Get it done, get it today. You don't need a gigantic plan to start moving to the cloud. You can take a POC, a proof of concept, and just focus on that specific small workload that will that can either give you great benefit and great impact within your organization, or is so simple and so easy to migrate that you will get a quick win there and get that feeling and get and from there get the buy-in of other stakeholders to help you on that journey. And once you're there, then move on to full production and understand what impact that brings to your organization. But if you're having trouble to get that buy-in from your organization, start with yourself as well. So on your own, there's so much that you can do. You have the hands-on training labs that are available online that you can take them, either using the free tier or being part on some events that are available within AWS free to get hands-on with the console without having those costs. And you can play around with things like Deep Racer and Deep Lens and Deep Composer. And these are playful ways to learn where you can interact with other people in terms of Deep Racer and get races. And today is virtual, but once we get over the pandemic, we will return to physical races where you get your cars and put your machine learning algorithms into it, and it's quite fun. You have the competitions online, quite fun. So get hands-on, get integrated into this, get familiar with things. My personal perception is that in terms of computing, this is the future. Okay, so big thank you for everyone for listening so far. Thank you again for Ahmed. I will ask you, Ahmed, how are we on the demo? So did it work every well? And yes. Also bring John again to help us with questions from the audience.
Ahmed, is there any update on the demo, or should we move to the questions?
Yeah. No, so it's finished, so I can't take back. So if you make me presenter, yeah.
Okay. I've given you the screen, Ahmed.
Yeah.
Brilliant.
So yeah, so you can see here that it successfully finished. So quickly, let's go to Cognito. Here you'll see a user pool was created. So a user pool is a user directory that enables you to add sign-ins and sign-ups to your application. And you can also add federated logins like Facebook, Google, Amazon inside your application. Anyway, so here we're using the normal login. So let's add a user, create a user. And then this could be any number. Okay, and then any email. Okay, so user was created. Now, if you go to the application, okay, and then let's add the user. So previously it gave us authentication error. Now, still authentication error. Yeah, so now it worked. So now we're able to log in. Obviously, you will not see anything when you log in inside because the API part is not added yet. So as George mentioned, in 15 minutes, we're able to deploy a web application and add authentication to the web application. The code was there, let's be honest, but still, from repository to production in 15 minutes, still quite good. Thank you.
Thank you, Ahmed.
So now we're open for questions.
Okay, there's an interesting one from Julian, and I'll put two together. If the original app is still available during deployment? Can the new app capture interactions on the old one? And what about migrations of legacy apps that can't run on the latest operating system? Some clients, he points out, are still running Windows NT.
Yeah, so Amplify is used for in this example here that I've shown you. Amplify was hosting the static content in S3, so it's not operating systems. You don't need to worry about operating system and all that stuff. And this is the first thing. Now, second thing, first part of the question I think he asked is if the new app, if the old app is still up and running and the new app is getting updated, how will the user updates will be captured? If I understand, is this the question?
Yes.
Yeah. So this should be fine because any application will be powered by a database at the back end. So any updates will be written to a database, and the new app, when it comes online, it will point to the same database. So it should be fine. So in fact, if they continue using with the same link that we will share with you, the workshop, you'll be able to see that they will add at a later stage DynamoDB table, and it will be powering the application as a database.
Thank you for that. Here's one that a lot of the audience might be interested in. Mark asks, how are the IP ownership rights of the code and content protected to the developer? George, what do you think?
That will, I would say that is a question more about content within GitHub or public content. It's not so much in terms of AWS. Please correct me if I'm wrong, Ahmed. So AWS will be agnostic in that perspective. Am I right?
Yes, correct. So the customer always owns the data, their data, and this data, any code is considered as data as well. So we do not own or we do not have access to any data that the customer data or customer content, like code, for example, and everything is owned by the customer side. And if the customer are using like a third-party Git-based repository, like GitHub, for example, then it will not be even hosted on AWS.
Here's an interesting question. Raj asks, how easy is it to migrate to and from other cloud providers? And you might like to take Abdul's question as well. He says, I prefer AWS. Some of my colleagues prefer Azure. How do I convince them that AWS is better for us?
I'll answer picking up from the previous question. So workloads, for example, on Windows NT, AWS covers a wide range. We could say almost all types of workloads with different types of solutions. So we can bring in Windows NT, for example, or mainframes, that sort of thing, all type of workloads in terms of IT. If AWS, how to convince other people to use AWS instead of another provider? What we usually look is what the majority of the customers within the industry do. And according, for example, with Gartner, we are, for the 10th consecutive year, we are in the lead in terms of cloud provider. And we also see that we run the majority of the workloads on the internet, and we continue to expand these numbers. The reasons why customers actually move to the cloud, though these are different reasons, I named a few, but for each workload, there are advantages that can be addressed specifically. What I would recommend is to interact with the account manager for your AWS accounts, and they will help you to identify those benefits.
Ahmed, can you add to that?
No, I think George said it all. I'm not sure. I think also one point that would be important is there are different, I think George already mentioned this, there are different migration paths depending on the workload. And and we call them the 7 Rs. And there is more information available on our website. And this is something that maybe we can share with you. It depends on the workload and the use case.
Good, thank you for that. There are many more questions, but the clock has caught up with us, so we'll have to stop there. But thank you very much indeed, George and Ahmed. You've given us a fascinating overview of AWS and set the scene for the two further really interesting sessions on the 11th and the 18th of March. We will share the recording of this session with you in the next day or so, and we'll include some good links in case you want to deepen your learning around AWS Cloud as well. When you close this session, you'll see a survey. It's a very short one, and we would really appreciate hearing from you about how you found this session. And if you're in a rush right now, don't worry, the link will be included in a feedback email in an hour's time. I hope you've enjoyed this session. Let us know if you'd like to attend the next ones. Thank you to AWS. Thank you to our speakers, George and Ahmed, and thank you for attending. Goodbye.
Thank you.